guys, we have a very special episode of Nerding Out with Sasha here for you today. We are joined by Nelson Hartley here in New Zealand. Nelson, thank you for joining us here.
No problem. Well, I didn't have to travel very far, so for me, it's relatively easy.
Well, then thank you for having us.
Perfect, yeah.
Yeah, it's amazing to be here. So
yeah, cool. Glad to have you guys here.
Yeah. So, Nelson, I don't know if you remember, but in one of our earliest conversations, or my earliest conversations with you, I said to you, I'm a little bit worried that we're building a new engine, and I see it as a risk. And you just said, why? It's only an engine.
Well, it's literally just an air pump.
Just an air pump, okay.
It is, I mean, thousands of engines have been built before by men and women with 2 arms and 2 legs, or sometimes less maybe. Like, you know, what's the difference? We're all mere mortals, so it is just an engine. Now, I say that, it's obviously a bit more work than just waking up one morning and building an engine, but it doesn't have to be complicated. You just bite it one mouthful at a time and work your way forward.
Awesome. Well, I wouldn't know where to begin, but I think you'll tell us a little bit.
I love the humility as well. Yeah. It's just an air pump. I mean, to me, it's like a work of art, obviously, right? And to all of us, we're creating this highly emotional, piece of engineering and design, and then it ultimately comes alive, and there's a whole different dimension to it. And I just love how kind of no nonsense your attitude is from day one, of just kind of boiling it down to what needs to be done and going about it in the most humble but expert way.
Yeah, I mean, I'm proud of what we've done here. Yes, I say it's just an air pump. It is more than just an air pump. It's an engine, and it serves a purpose. It drives a car forward, but it's also a piece of art. Mm-hmm. We're attracted to these things because they do emotional things for us. So that's how we treat the engineering in it as well. Like every little bit of machining, or the way it looks from a distance, the way it looks up close, I treat that as an art form. But I also think engineering is actually a form of art. I know it's often pushed into more with science or maths, but it is just as much art. And I always joke that we'll make it up because we're engineers, and engineering is just guessing with better maths. So there's a bit of art in that as well. I say that jokingly.
Again, boiling things down to the essence.
Sometimes you look at the bigger picture, sometimes you look at the smaller picture, but I think it's a good looking engine. I'm proud of the simplicity of it. Hopefully awesome. The function long term is just as simple but elegant, or raw, because it's going to be pretty loud.
Yeah.
It's incredible.
It's awesome, yeah. So I think that Sasha came at you with a briefing that it needs to be a V12 and a hot V.
Yes.
So maybe Sasha, maybe you can talk a little bit about why you wanted that, and we can talk also a little bit about what is a hot V, because I don't think everybody knows what that is. So let's start first with the why.
Yeah, I mean, it's, I guess, pretty straightforward. I mean, I kind of fell in love with the world of cars through Formula One, actually. I started watching F1 in early mid-90s, and that was still the V12 era, and I very much remember the 12-cylinder cars, and it felt to me like every time regs would change, it was only ever getting worse. Like there was the original kind of thrill of the way those engines sounded in the early 90s. It just sort of first got downgraded with a 3.5 liter jump to 3, and then the next step was V10s, and then the V8s at 2.4, and now we're at V6 and it's turbo. So it just felt like all those earlier engines were great, but the V12 was the greatest one of them, and then it was kind of step by step going into a more neutered, more kind of efficient but less exciting status quo that we're at right now. So when I'm dreaming of building my own hypercar and starting my own car company, it was kind of you couldn't look past the V12, basically. It had to be a V12. And I also thought that it's the heart and the soul of the car, and it's the last thing that I want to buy off the shelf.
That's fair.
We got to find someone who can be as creative on the engine side as we feel we are on the rest of the vehicle and the design side and the brand and everything. And then finding you and your team and your company was, I don't know, somewhere in the stars, I guess.
That's a nice thing to say.
That's how it feels. And why hot V? Well, actually, for a couple of reasons. There's this one particular engine from Formula One that I really like visually, and it's not necessarily a hot V because it's a flat, but it's got the exhaust up and out from the flat block, and then it's a 1969 312 Ferrari Formula One engine. It had the white spaghetti exhaust, and we kind of copied a little bit of that aesthetic with our show car build,
Yep.
with the white ceramic exhaust, and I just felt that for me, right, referencing Ferrari a little bit too much, I guess, but what I love about those old engines is that you look at them and you understand the function. Nobody even needs to explain to you what's going
Exactly.
on. And that purity is something I thought that the Hot V layout really helped communicate, because it was so evident what is going on, right?
Yep.
Where the air is coming from, where the work happens, where the combustion takes place, and then where the exhaust is coming out of. So that self-explanatory nature of this setup is what attracted me originally. But then, of course, there is advantages to the way the heat situation works out, with cold side being down low and hot side being up at the top, and they don't contaminate each other. And the routing of the exhaust is far simpler than having to go around eventually the suspension wishbones and around the engine block, around the transmission. This is so much more straightforward. So
it
just
has
love the
worked out
aesthetics
that way,
of it.
yeah.
But I don't know, Nelson, maybe just passing it over to you so you can nerd out.
Yeah, so the idea of the hot V, which, to your further question, what is a hot V, just means that the centre of the V is really, really hot, because that's where the exhaust is, I guess. So just slang, I suppose. Exhaust out of the centre of the motor as opposed to the outside. Straightforward. When Sasha first talked to me, I actually have no idea how you found us, to be perfectly honest, but
there was a mutual connection there. Yeah.
We got on a call. I was pretty ignorant, to be honest. I didn't really know who you were. I looked it up and I was like, well, we just designed some pretty cool cars. That's pretty sweet. And you showed me some pictures of the car and I was like, whoa, that's pretty cool as well. And I feel like you actually really walked me towards the idea of a hot V. You didn't come straight out and say, can you build us a bespoke engine with the exhaust out of the centre? Like, that was not even part of the first conversation.
No.
Or not the first part of the conversation anyway. Because we have a OEM-based, like a Toyota-based V12 that we build a few of. Not a lot, but for like drift cars.
Just let me interrupt you for 1 quick second here. The reason I didn't come at you right away with a hot V is because I actually at that point in time did not know how much flexibility we were going to be looking at.
Right.
I thought maybe they already have an engine that will be 99% of what we need, and it's just going to be some little bits and pieces. And then I realized, no, we're in it in a way that we can be more creative and we can start from first principles, and that's where the hot V was always in the back of my mind. I just didn't know when the right moment would be to kind of smuggle that idea.
Yeah, right. Because I mean, I think that worked out well, because you got me buy-in from me on your project, because I liked the car, and then I think you first said, what do you think of the idea of a hot V? And I'm pretty sure my first comment was, nah, that's a dumb idea. Well, why would we put it there? Not because it's a bad place to put it. The engine doesn't care. I was just like, well, V12 is normally 60 degrees. It's too tight. I don't know how I'm going to fit that in there. And I think I just sort of pondered on it that night. And then that weekend I drew something up and I was like, actually, that's really cool. And it's sort of just the idea exploded from there. I probably sent Sasha a CAD model within 24 or 48 hours of an exhaust system, an engine laid out with the exhaust system coming out the centre. And he got excited, so I got excited.
First of all,
we
I got excited
at that stage. So
I got excited that we're working in the same way, because from idea to the first CAD drawing for me is also like usually a day or two, and sometimes the engineering partners that you'll find and you work with have so much kind of, their process is so overextended. First you need to work on the commercial agreement, then you have the project management, then you lay out your milestones. And I get it, all this stuff needs to be done, but ultimately we're just creative dudes, right? And we just want to build cool stuff. And I just love the fact that you just got on with it before we had anything really in place, just because the excitement was there.
I was like, I trust these people, and so what? Like, you're not going to have good ideas and do things if you don't get to work and do it.
Right.
So, like, it was cool. Yeah. And putting to be honest, the very first drawings I did, like the layout of the exhaust hasn't actually changed much. It's just sort of refinement on how it fits and the lengths. And I got carried away with that. I was like, once I realised the industry you guys have been working in, I was like, well, I want to impress this guy too. Well, these people, this team, because I didn't really know. And always, I try to impress myself and everyone else. We want to do cool stuff. So I actually put a lot of effort into that very first concept, like equal lengths, nice shapes. And the more sometimes you close the gap on the finer features and not just the concept, actually brings the beauty out of it as well. Because I personally think there's a lot of beauty in, what would you call it? Like, when I look at a race car, especially in a category I know, like I spent my youth growing up watching like racing go-karts, and I go to the track, and you guys might not see it, but I see a kart and it's got the right wheel offset for the track conditions that day. To me, that's beautiful when I look at it. I know it. So I feel the same about something like an engine. When you put the step and the header in the right place, to me, it's like, that's there for a reason. That's beautiful. So it's the same thing with a motor. That's probably the same with anything.
I think we have a very similar approach to what beauty actually means, how much it's related to the purity of the concept and let's say the quintessential simplicity in execution, that, if something is confused in its conceptual form or executed in a way that is not as elegant as it should be, then it really doesn't result in beauty.
You're absolutely correct.
You need that foundation and the purity of execution to have that end up beautiful.
There's a lot of elegance and beauty in things that are simple but work extremely well. Like you take two mechanical items, one's got 200 moving parts and one's got 3 moving parts, and they both achieve the exact same outcome. To me, the one with 3 moving parts is beautiful, because it's like there was a lot of effort to get those 3 moving parts to do what something else required 200 moving parts to do.
And it's more often lighter, more reliable.
Absolutely.
And everyone benefits, and it's beautiful. So that's
I personally and my team as well, we approach all our engineering in that way. Like everyone here is passionate about cars and motors and just engineering in general, whether it's even things like a house that's designed simply or a shoe that's simple. Like we're all into things. But my entire team are all into cars. They've all got little projects themselves. So
That's awesome.
Yeah.
Yeah. So we just talked actually earlier today about, I don't want to name the engine, but we looked at another engine that was recently shown. And one of your commentaries was, there's just so much stuff here and I don't know what it's for. Well, so that's an interesting comment from an engine builder.
I found it very confusing. And a lot of cars I see, you lift the bonnet on a production car, there's a plastic cover over everything. When you pull that plastic cover off and there's just lines and pipes and fittings everywhere, and I get it, a lot of it's there for like emission systems and engine controls, but a lot of that, I apologise I left my phone on, but a lot of that could be shortcut through just a little bit more thought in the design. That line could be internal, it could be inside a casting, you could hide that somewhere, you could break it down, what is the bare minimum required to achieve this, and then start from there, rather than we'll just add another piece of tape to it. And some of the modern hypercars, some of them you can't even lift the bonnet because they don't want.
Well, we don't even have a bonnet, so
there's no hiding there. But some of them, they've just got so much crap on the outside. We might not be, maybe I'm missing something, but I'm struggling to understand why there's so much crap on the outside of something.
Right.
And even modern car design, I don't understand why there's so many
don't get me started.
louvers and air ducts. I think, I don't want to name cars because there'll be someone offended, but like even just some sports cars coming out of, say, Japan or something, and there's just all these louvers, but they're all like fake air vents to things. That irks the hell out of me.
They're all like blocked behind, so it's not actually functional.
And it's as simple as, an analogy I use is fake carbon fibre, like carbon fibre sticker looks horrible, real carbon fibre looks beautiful, but they look the same. So there's something else to what makes them pretty, right? And it's the function.
Right.
Absolutely.
So what about this engine in particular is special to you? Because I know why it's special to us. Okay. But why is it special to you?
It's special to me because this is kind of the engine we wanted to build in a roundabout ways. Like I definitely hadn't sat at home thinking about doing a hot V, but we'd wanted to do our version of a really raw, brutal, sort of high cylinder count competition engine built for the street, like usable motor. So it's really simple in that it has quite a low bill of materials in the motor, and that there's not as many moving parts as other similar engines. It's very light, it's very petite, like everything was wasted away in the design. And I just like that, and the way it fits together. Well, the way I think it fits together anyway. Me and the guys have really enjoyed bolting it together and pulling it to bits. It's the engine that if it was in the back of my race car, 'cause I've done a lot of racing, and nothing gives me more joy than unclipping a nice wiring loom or undoing a nice bracket to adjust something. Like this engine for me is that, as opposed to being stuff bolted to stuff that didn't need to be bolted to things, and you feel like you're doing work you didn't have to. I just love the way it bolts together simply. The cam cover's just one piece and it's got an O-ring around it, so it doesn't need any silicone, and it just bolts on nicely and it fits. Like things like that. Yeah, I like the simplicity of it and the way it's sort of come together.
We do too.
Yeah.
But would you say that it's kind of the quintessential result of all the years of engine work that
100%.
you have done that have led you now to this is not standing on its own. This is a result of a kind of lineage.
Like, absolutely. So we've been very fortunate in what we do for a living, and that, granted, it's a humble way. Humble? I don't know if that's the right word. It's not the most profitable way to deal with the automotive industry, developing engines for race categories, particularly not in this half of the world, because there's just not that level of motorsport here. But the race categories we do work in are normally classes with quite strict rules, but enough of an opening within the rules to develop, and the classes are competitive enough that it's worth developing. So competitors want to win. There's lots of competitors. There's lots up for at stake, but it's not just open rules, because open rules add more boost. It's that easy, right? Whereas when it's like a tight set of rules, like you've got a displacement limit and say a compression limit and an intake limit, well, then all of a sudden you'll do anything you can to beat the competition. So we are constantly, how big a piston can we get in that motor? How short can the stroke be? How big a valve? If we move the valve just like 0.5 mil, can we get some more air in the side of it to gain like 1%? So it's just non-stop development like that for very small gains, and you learn a lot. Like we'll develop a race engine and then make 8 exhaust systems and test them all on the dyno. They'll all be like 3% different just to extract that last bit. So really lucky, as opposed to just buying parts off the shelf and fitting them, because you can't develop with off-the-shelf parts.
And I mean, even things like, how refined everything is. It doesn't happen overnight. You can see that there's been so much, work and so many iterations done before you arrive at a particular shape.
Yep, that's absolutely true. And what I find interesting about it's like something like the piston. The piston top's a really important part of the combustion cycle. And a lot of it is not necessarily the result of that's the perfect piston shape, but it's the result of we need certain things, and we have a certain shape inside the cylinder head, and we have to have space for the valve. So that pocket's there because the valve needs to go somewhere. Well, that pocket's there because we need to hold the flame somewhere, and that lip's there because we need to push the fuel from the outside of the chamber to the inside so that the spark's making it burn and we're not getting detonation. So the shape kind of emerges as a result of the things we want it to do. Right. And I quite like that. It's a really interesting way of looking at the shape. Is the same as the exhaust. Like those little steps are there because at a certain point we want to stop the sound waves carrying back. So it ends up with a certain shape, or the shape of collector. It squashes in a certain way because we want to speed some airflow up in a certain point. It's not just because I liked that radius or that curve. And I quite like that in engineering, because sometimes you have a vision of what you're going to get, but sometimes it emerges out of the process. That's always quite cool.
Yeah, form follows function, and it's beautiful. Yeah.
So we talked about kind of what is special and what you like about this engine.
Yeah.
I want to talk for a second about the challenges. And I say that knowing that we've been waiting on a crankshaft now for a couple of weeks. So we've experienced some challenges with this on the supplier side. But I'm sure there were other challenges as well. What would you say is kind of an area that's...
To be honest, the biggest challenge is putting everything together in a short time period, because we've been working on conceptually like your car and the motor for quite some time, but actually sitting down and engineering on the engine, I don't know how public it is, but the engine that was in the display car is very different to this engine.
Sure.
I sent Sasha some CAD models late last year, and he came back to me and he said, well, this is nothing's the same as the first one. I was like, no, the first one was engineered so that I knew roughly where we were heading, and then we could do a display engine. This was a whole clean sheet, and I think I started that in November. So a pretty short period of time from that to having an engine ready to run. That side of it is not a challenge. The design, the challenge is we have to make it work with the car. We have to make it match the gearbox. Probably, to be honest, the biggest challenge is just because it's so big. Where do we fit a clutch? Where do we fit a release bearing? How do we get that around the bulkhead of the car? That's a little bit of a challenge, and that's just back and forward. You solve those issues. To be honest, the biggest challenge has been now we need to make it, and now I have to draw on all the because we can't do everything in-house. No one makes anything themselves. Like, I think it was a lecture by Milton Friedman. He held up a pencil and he's like, no one person makes this. Someone chops down the tree. Someone mines the carbon. It's the same. Like, there's certain things we have to outsource. And we typically outsource our crankshaft manufacturing, for example. Casting, we're not a foundry, so we have to design the parts and then work with the foundry about the tooling style, and they have to cast it. So there's always things that get outsourced. The biggest challenge is just getting all that to come together in a short period of time. Production is a completely different scenario because you can project forward and say, okay, we're going to need 10 of these over a period of 6 months. It's so much easier because once they start flowing in, but when it's like short time frame to get the first one running and you're like, we need this going, we want this going, we want to see it running, and then getting everything to turn up, probably that's been the biggest challenge. There's some lessons in it. There's some parts that we would typically outsource. For example, the camshafts, we normally work with a company that just make blank camshafts. That's all they do. So I send them the drawings, we work back and forward a bit, they make our blank camshafts. They had some issues in their factory. They had to shut down, move facilities, couldn't get power turned on for a particular machine. We grind all our camshafts in-house because it's a very particular piece of quality control we want to be in charge of. Yeah, there's a camshaft. Yeah. So the issue there was the camshafts are now ready, the ones that we commissioned to get made, the blanks. We'd still have to grind them. They'll probably be here next week. We want this running today. So there was a bit of stress. We have the machinery that can make that from scratch, but we don't typically make, when we make round parts, we make small, like any size, flywheels and pulleys and things. But machining that is quite different to machining something very thin and something long. You get a lot of chatter. Our machine just was not set up for it. I hadn't machined a lot of long things that are going to chatter, and so there was a lot of setting up our process for getting like, I didn't want to we could have roughed it out and had an ugly looking part that still worked, but I didn't want to put an ugly looking part in the engine. So just getting that to work, okay, what's the method of manufacturing this? It probably took 3 weeks to get that right. Now we can make camshafts easily. We've actually solved a problem I didn't wish to solve, but now I don't have to wait for someone else to make camshafts. There's a high chance we'll probably end up doing the same with crankshafts. Thought a little bit about it after this drama. Like, yes, we actually have a machine that can make crankshafts, so we might start making them in-house. There's a few little things to research, like, okay, when do we stress relieve them, when do we heat treat them, when do we post grind them, but the problems that can be solved because other people solve the problems. So that's how we approach everything.
Yeah, that's been pretty much your approach to everything.
If someone else can solve the problem, so can we.
Why can't we?
Right.
Yeah. And if you have that mindset, you'll normally go out looking and find a solution one way or another. Or you'll fail, and then from that you'll learn how to do it, or you might fail again.
Well, that's why we're in prototype stage.
Exactly. But I would say for the most part, everything has gone well except for a couple of supply chain issues, which have been quite stressful.
Right.
But, they're just problems to be solved later on. Production's a completely different animal because you can project forward so much. But prototyping's challenging.
Okay, great. Well, I've got one final question for you. I have to bring it up since we have you here, and that's Brandon, your brother.
Oh, yes.
Who, for the audience out there, if you guys don't know, Brandon is a Le Mans race car driver.
Yep.
3-time champion and an ex-Formula One driver as well.
That's correct, yep.
So does he want to drive the Nilu?
He really does, actually. We've had lots of... So it was interesting. So yes, my brother is a professional race car driver. I'm biased. I really like him, so I think he's pretty good.
We like him too.
Yeah, I always say that I got the looks and he got the talent. So
we won't tell Brandon that.
I think I stole that quote from someone else. When we were walking around at Pebble Beach together, a few people came up to you guys and said, "Oh, I'll be the test driver." And on the back of my mind, I was like, I know a guy.
That's awesome.
Yeah, he would love to. He's very supportive of this. Like he had Le Mans on the weekend. And I don't normally hear from him on a race weekend. Like, he's pretty busy. There's a lot on his mind.
Can imagine.
Well, he rang me, must have been Saturday morning, and I was like, "Oh, what's up?" And
Just before the start?
Yeah, it was probably 2 hours before the start of the race. And I was like, "Oh, do you want to talk about the race?" In case he wanted a heart-to-heart. And he's like, "I don't care about that. Have you got the engine running yet?" So that's cool. Like, he's pretty excited too.
Awesome.
That's awesome.
Very good. Well,
and he's met you guys as well. So
yes. We visited him in Monaco, and he was wonderful to meet him. And
I imagine there's a lot of people that will want to test drive this car.
There are, yeah.
But we'll keep it in the family.
Well, awesome. Well, thanks a lot. This has been a great chat.
No problem.
Appreciate having you here with us, or us being here with you.
Yeah, it's cool. Yeah, perfect.
It's the other way around. And then, first and foremost, thanks a lot for the talent and for the passion and for the love and the care that you and your team have put into this beast of an engine.
Everyone here is excited about it.
We are. Yeah, I can't even put it to words how excited I am.
We're awaiting egerly the first fire.
Yeah, hopefully it's tomorrow.
Yeah.
I've been on the phone to DHL a lot. The crankshaft's meant to be here first thing tomorrow morning. I'm thinking, because we've assembled this engine 4 or 5 times now, like every nut and bolt is bagged out and laid out. We know.
Perfect.
We've got a couple of tolerances to check. Even if they're out, we have contingencies for it. We should have it assembled in 4 or 5 hours.